Sanibona guys, thembe niyaphila nathi siyaphila. Here we are still on the strain energy and we are given this type of question, and we are given this type of question whereby they say whereby they say a steel bar of 25 millimeters in diameter and 1.22 meters long absorbs 65 Newton per meter of energy at its limit of proportionality under axial loading. Bese bathi calculate the stress induced in the bar. Okay, guys, I hope you remember what I said to you. I said everything that will feel a strain energy kuzobe kuyiphi kuzobe kuyile onikwe yona area nelento yakhona. So in this case we see that is the steel that is going to feel any stress and absorb the strain energy here. So since here they say, okay, calculate the stress induced in the steel bar. Here they didn't clarify the stress CP, it's either gradually or suddenly or impact loading. If they didn't clarify that thing, what you do, you just have to go and pull up this equation, of which it's a Bohm equation for you, which is a strain energy equation equals to 2E times V. Right, this equation is the equation that you are going to use whenever they say calculate the induced stress, but they didn't say what is stressless or is caused by a gradually or suddenly. So hence the stress also stolen up using this equation, it's called instantaneous stress. Right, it's instantaneous stress is the stress at any point. That's the meaning of instantaneous. Right, okay, looking at this equation, we have everything so far. We have the strain energy we are given as 65, we have E, and we have volume, because we know this is A times L. Right, so we want this stress. Right, if I can substitute into this formula, I will have what? My 65 is equals to the unknown stress, then I will have 2 is 200 times 10 to the 3 times the length of the road. It was what? 1.22 times the area. The area for this it's pi over 4, right, and it's 25, meaning it's 0.25 squared. Then I get my answer. You will get the positive and the negative answer, but in strain energy we only focus to a positive answer. Then my positive answer here, as a result, I get it to be 0, it's 20837 megaPa. This is the instantaneous stress. It's whereby they didn't mention what it is the stress. It is the stress caused by a gradually or impact or suddenly. Right, okay, next they said calculate when is gradual. Calculate the load when it's gradual. Right, they want you to calculate the load when it's gradually. Okay, you know what for gradually you have this one. No, this is stress P over A. Right, they want the force when it's gradual. This stress, it's instantaneous stress, is the stress at any point. You can use this stress to find the load of gradually, to find the load of suddenly, to find the load of impact loading. That's why it's called instantaneous. Kahle kahle ushaya zodwa usebenza kuyo yonke indawo, right? So I can, to find my force, right, caused by the gradual, since this is the gradual equation, I know my stress, of which is the instantaneous stress, I know my area, then I can find P. So I can say P for gradually, it's going to be the stress, which is 208.37 times 10 to the 6 8 pi over 4 multiplied by 0.025 squared. Then I get my answer to be 102.28 kilonewtons. Right. Then the next question is what? Calculate the load when it's applied suddenly. If it's applied suddenly, we know that the formula for suddenly is this. It's area times 2 this. Meaning, right, I can say P is equals to stress A all over 2, right? Meaning the gradual load, right, it's what? It's half of the sudden load, it's half of the gradual load, right? You can see I will have the instantaneous in the same area, but divide by 2, of which these 2 come from suddenly, where we multiply the force by 2. If you want to calculate it, you can insert this instantaneous stress, of which is this, and the area, of which is the same area, then you put a 2 divided by 2, or if you want to be quick, you can just take this answer and divide by 2, of which is 51 my 51.14 kilonewtons, right? If you have the gradual and they ask you, if you have the gradual load and they ask you the suddenly load, you have to divide the gradual by 2 and get your answer, right? Simple like that. Now we are moving to to what? They want your load when it's dropped into a height. We suddenly know that it's an impact load. And for impact load, what do? We pull up this equation right here, of which is say U is equals to P. It's not M, it's H plus change in X or L. But already, right, what do we have? We have this part here, right, of which is what? Of which is 65, right? Then my P, I don't have this P, right, because this one is for impact load. But I have the height. Which height? The height is the height of which the material is going to be dropped. It's going to be dropped at 120 millimeters high, right? So it means I have what? I have my height. Then the change in X, I'm not given the change in X, but I know what change in X or change in L is equals to P. It's P over A E L, right? How do I go about that? Now I will put my 65 here is equals to P, right? And I go to this, the height, it's they say is 120 millimeters, of which is 0.12 plus. Then I go to this instantaneous, because this thing here is the instantaneous change in length, right? What I'm going to do to this P, or to this force over area, which is the stress, I'm going to insert instantaneous stress, right? So I will have 208.37 times 10 to the 3. Then the length is 1.22. All over the area is this times 0.025 squared times E, which is 200 times 10 to the 9. From here you can get your P to be 536 Newton. That's my P for my gradual, no, for my sudden, for my impact loading. You see what have we done? They ask us to calculate the stress in joules in the bar. We've used the instantaneous equation, of which is the strain energy equation, this equation right here. Then we get what? We get the stress. The stress that we got there, it's instantaneous. Why? Because they didn't mention that the stress is caused by which type of load, right? So we conclude it to be an instantaneous, meaning is the stress at any point. We can use that stress to find any force, gradual force, sudden force, and impact force. We can use it using the instantaneous stress. Hence they ask for gradual load. We say we know the formula for gradual load is just force over area, but we want the P, and someone will ask, where is the Q, or the stress? The stress here we have it is the instantaneous stress. Job being issued is the stress at any point. Then the area we are given, then we calculate P, right? Then we move on. They ask for suddenly we know, which we just have to multiply the force by 2. So the stress is going to be stress equals to 2P over A. But for simplicity, if you were asked to calculate a gradual, then next they ask you to calculate what? Sudden. You just have to divide the gradual by 2 to get your suddenly force, right? Then we move forward, and they ask for a impact load when it's applied, when the height is 0.12. Okay, we pull up this equation here. Then what is happening? We have our U, which is our strain energy. Then the P is the unknown P that we don't know. The H we are given, which is P from 120 millimeters. Then the change in X. The change in X, we are not given the change in X, but we know the change in X can be replaced as this form, right? If I change it to this form, I see what I have: force over area. Force over area stands for the instantaneous stress. If I'm using this change in length here to be this, it means this thing is the also instantaneous. It's also instantaneous elongation, right? This is instantaneous elongation. I get the instantaneous elongation in terms of this, and I can place it here. Then I calculate for my P. Others, if you don't wanna do this, do you remember I said to the first video, for the gradual load you can do this and say it's 1/2 P times change in L, right? If you want the gradually, you already have this 65 here, right? Then the change in L, you are going to calculate it using this. It's P over A times L over E. You use the instantaneous stress here, of which is 208,37 times 10 to the power 6, and the length of it 1,22 all over 200 SE times 10 to the is G, it's 9. Then the area, it's pi over 4 times 0,025 squared. Then you get your change in length to be 1,271 times 10 to the power minus 3, right? If you don't want to use this procedure, you can use this, whereby we know from the first video, which is 10, the gradual for the gradual load, this is the strain energy equals a gradual load. But now I have what? I have 65 as my strain energy. Then I have what? 1 over 2. I don't have P, but I have the change in length to be 1,27 times 10 to the power minus 3. Then I solve for my P here. Then the P will also be 2,28 kilonewton. Now ungenzele lapho to prove ukuthi kuyafana. Mina sengikuthathele ekhanda, but it should be the same. If we come up to this, we know for suddenly we have this equation. The strain energy that is caused by suddenly is just U equals to P change in length. We have this, which is 65, and we have our change in length, of which is this one, is the same because it's instantaneous change in length or elongation. It's 1,27 times 10 to the power minus 3. Then this is P, which is equals to 51,4. It's 51,14 kilonewtons, right? And moving on to what? To the strain, to the impact load. For the impact load, what we are going to do, again, going to have this equals to P, so G, not G, it's H. My P, H plus change in L. I have this to be my 65. I don't have P. I'm given 120 millimeters to be 0,12 meters plus the change in length, the instantaneous change in length. It's what? It's 1, is right here. It's 1,27 times 10 to the power minus 3, right? And solve here, and I should get 536 Newton, right? So it's up to you which method you want to use. You can firstly calculate the instantaneous elongation and use this, or you can just use the stress formulas. Okay guys, into engifuna nibambe futhi manje, the instantaneous elongation, it is the elongation of which you can use noma ikuphi to find whatever that you want, right? So into yaze yathi instantaneous, it means at any point it applies to everything that you are doing, right? So we will stop here for today. Thank you.